A particle of mass 50 gram moves on a straight line, force acting on the particle at t equal to 2, 4 and 6 seconds. So here this is the graph given to us. We have to find the force acting on the particle at time t equal to 2 seconds, t equal to 4 seconds and t equal to 6 seconds. So now this is a velocity time graph. And as we know, if velocity time graph is a straight line inclined to the time axis, then the slope of velocity time graph will give us the acceleration. And from that acceleration, we can calculate the force by using the formula called as F equal to ma. Okay. So now let's look at the slope of this line from 0 to 3. From 0 seconds to 3 seconds, there is this velocity line. Okay, this is the curve, velocity curve. Now this is a straight line, so finding the slope is easy. So let's say slope of, let's say this is O and this is A. Slope of line OA will be, let's say this is our x2, y2. The point A's coordinate is x2 and y2, and this is the origin. So slope formula, as we know, y2 minus y1 divided by x2 minus x1. So what is it? This is equal to, what is y2? If I trace it here, we can see that y2 is 15. So y2 is 15 minus y1 is 0, because we have taken this 0 origin as our x1, y1 coordinate. So now x2 is 3 here and x1 is again 0. So we get 15 by 3, which is 5 meter per second square. So the acceleration at time t equal to 2 seconds will be 5 meter per second square. So acceleration between 0 to 3 seconds will be 5 meter per second square. Okay, because velocity time graph's slope will give you the acceleration, and the slope of this line will be constant from 0 to 3 seconds, which is 5 meter per second square. So now you got acceleration at t equal to 2 seconds. Now for 4 seconds and 6 seconds, similarly we can say that, let's say this is point B, this one. So slope of line AB will be how much? You can see here, if I take this as x3, y3, okay, and this A as x2, y2 again, then the slope will be y3 minus y2 divided by x3 minus x2. So this will be y3 and y2 are same, which is 15 and 15, so this is 0, and x3 minus x2 is 5 minus 3, so which is 2. Now this is 0, so this is 0 meter per second square, which you can directly see from this line AB. AB is a straight line which is parallel to the time axis, and hence it has no slope, so it is 0. So the acceleration becomes 0 meter per second square. Now in the third case, slope of this line BC, okay, this point is C, suppose the slope of line BC will be, let's say the C's coordinates as x4 and y4. Again similar procedure we will follow. So slope of line BC will be, since the C's coordinate are x4, y4, we will write y4 minus y3 upon x4 minus x3. So this is equal to y4 by minus y3 divided by x4 minus x3. So y4 is how much? 0. Y4 is 0, and we know that x4 is 8. So this is 8 minus, what are x3 and y3? x3 is 5 and y3 is 15. x3 is 5 and y3 is 15. So this is minus 15 divided by 3 meter per second square. So this is minus 5 meter per second square. So this is the acceleration at the time t equal to 6 seconds. In similarly, as in the case of the previous acceleration, that is when we were calculating the acceleration from 0 seconds to 3 seconds, the acceleration was constant, right? So here also from 5 seconds to 8 seconds the acceleration will be constant. So at 6 seconds also the acceleration will be same, which is nothing but minus 5 meter per second square. Now what is the force acting on this body? Okay, the force acting in this body at t equal to 2 seconds will be m into a. Now acceleration was 5 meter per second square and the mass was 50. So 50 gram into 10 to the power minus 3. So this is converted into kg, and acceleration is again 5. So this is Newton. So this is 250 into 10 to the power minus 3 Newton, or I can say that it is 0.25 Newton. This is the force at time t equal to 2. At time t equal to 0, the force will be 0 Newton because acceleration was 0. And force at time t equal to, sorry, not 0, okay, this is 4, time t equal to 4, and time t equal to 6, the force will be 50 into 10 to the power minus 3 into 5 meter per second square. This is minus, okay, minus 5. So here the force is acting in the opposite direction. So here it will be minus 250 into 10 to the power minus 3 Newton, which is nothing but minus 0.25 Newton. So this is the force.